All right, so today we're going to review how to algebraically find the domain of a radical function, specifically the square root function, and just reminding ourselves that the domain is all of the possible inputs of the function. So in this case, our inputs will be x because we'll be taking the square root of those inputs. Now, the most important thing to note about the square root function is that we're going to be taking the square root of x, and we know that we can only take the square roots of numbers that are 0 or bigger. I can't take the square root of a negative number at all. So I know that if I'm going to take the square root of this x, it can't be negative. I know that this x must be at least 0, if not bigger. So our domain is all of the x values that are bigger than or equal to 0. Now with that mentality, we can do anything we want. We can have any expression under the square root. What I know is if I'm going to take the square root of something, I'm going to take the square root of that box. Whatever that box is, I don't know. But what I do know, that whatever that box contains, whatever number that is eventually going to work out to be, that number must be bigger than or equal to 0. There's no questions. If it's not bigger than or equal to 0, I can't take the square root of it. So then I ask myself, well, what is that box? Well, that box is x plus 1. Okay, so whatever that box is, x plus 1, it has to be bigger than or equal to 0. So if I subtract 1 from both sides of this inequality, I know that x must be bigger than or equal to negative 1. So the only numbers I could put into this, if I was trying to make a table, so I could sketch a graph, negative 2, negative 1, 0. I can't use negative 2 because negative 2, if I plug that in, negative 2 minus 1 or plus 1 is negative 1. I can't take the square root of negative 1. Now if I plug in negative 1, the square root of negative 1 plus 1 is just really the square root of 0. I can do the square root of 0. If I plugged in 0, I get 1. I can do the square root of that. So we see this is where our border is. The only x's we can use are bigger than or equal to negative 1. Now coming to this example, again, if I'm going to take the square root of something, so I happen to be taking the square root of this box, whatever this box is, I know that whatever it works out to be, it has to be bigger than or equal to 0. Otherwise, I can't take the square root of it. So my next logical question is, okay, well, what is the box? Well, the box is 2x plus 6. So 2x plus 6 is the box. Likewise, if I'm going to take the square root of that number, it has to be bigger than or equal to 0. So in this case, I am going to solve for x. I'm going to subtract 6. So I get 2x is bigger than or equal to negative 6. And then we'll undo multiplying by 2 by dividing by 2. So we can see that the x values that we're able to use must be bigger than or equal to negative 3. Now another really important example is we can see that these equations start to get a little more complex, like they might throw stuff before or after the square root. But it doesn't matter. All that matters is I can only take the square root of something that is 0 or bigger. So in this case, that box, whatever it is, that box has to be bigger than or equal to 0. So I might ask, well, what's in the box? And we can see that it's a negative 2x. So I know that negative 2x must be bigger than or equal to 0 because that's what I'm going to take the square root of. Now this example is very important because we have to remember that if I'm going to get x alone here, I'm going to divide by a negative 2. So it's important to note that when we divide or multiply by a negative, we have to flip that inequality sign. So instead of being greater than or equal to, after I divide by a negative, it becomes less than or equal to. So here I can only use numbers that are 0 or less. And that makes sense to me because the numbers that are 0 or less is 0 or negative numbers. Now I'm not actually taking the square root of a negative. If I plugged in a negative number, like let's say negative 2, when I plug it into the equation, the negatives cancel and then it turns it back into a positive. And I know that I can only take the square root of positive numbers. And our final example looks the most complex. We can see that there is a negative and a 1/2 and then something at the end. But all we're trying to remind you is that for the domain, none of those things make a difference. those aren't our inputs. We're going to put something into the square root. Whatever I put into the square root must be bigger than or equal to 0. So what is being put into the square root? Well, that is the number negative x minus 4. That number must be bigger than or equal to 0. So I add 4 to both sides. So I get negative x is bigger than or equal to 4. And I don't want negative x, I want regular x. So I'm going to divide by a negative 1, which means that I get x, and I have to flip my sign. So rather than being greater than, I'll change it to a less than, and negative 4. This means if I'm going to make a table to graph this, my table can't have any x values that are bigger than negative 4. I can only start at negative 4 for my x values and choose numbers that are less than that, like negative 5 or negative 6, so on and so forth. So here's our summary of what we learned during this video. The only thing that makes a difference on the domain of our square root function is we cannot take the square root of a negative number. So whatever's under the square root can't be negative. It must be bigger than or equal to 0. So what we do is we take whatever's under the square root and we set that bigger than or equal to 0 and we solve. And our resulting inequality is our domain.